Hello and welcome to the final round of multiple linear regression. This is the final round because, as you can see when we go to our data set, we have 4 independent variables and 1 dependent variable. So that means that if we wanted to add a visual step by plotting a graph, we would need 5 dimensions. So that's a little hard to represent. So we won't be plotting a graph for this model, but that's going to be the only one. And so the final round, the final step for this model is going to be the prediction of the test set results. So let's do it right now. It's only going to take us one line. It's actually exactly the same as for simple linear regression and any type of regression actually, because you'll see that in the end, all our models' codes will look the same. So indeed, what I only have to write here is to create the vector of predictions that I'm going to call ypred, as for simple linear regression. And then I'm going to use my regressor. And I'm going to use the predict method, here it is, to predict the observations of the test set, which is xtest. All right. Okay, so if I take xtest again, these are the independent variables with the 2 dummy variables here corresponding to the countries. I think it was California and Florida. And then we have the R&D spend, the administration spend, and the marketing spend. So we're going to apply our regressor and especially the predict method to predict what would be the profit of all the startups thanks to the informations we have here. And then we will compare some predicted profits with the real profits. So let's click on OK and let's select this line and execute. Here we go, the vector of prediction ypred is ready. So let's have a look, ypred. And here it is, these are all the 10 predicted profits for our 10 observations. And I'm also going to open ytest, which contains the real profit. So we're going to compare the real profit and the predicted profit for some of our 10 observations. Okay, so this column here, this vector is ytest, which contains the real profits, the profits of the 10 startups in the test set, and that's the profits that happen in real life. And this column here is the vector of predictions. That means the profits predicted by our model. So now we're going to compare some of the profits because each of the line here corresponds to the same observation. So for example, if I take this line, this corresponds to the same observation of the startup indexed by 2 in the test set, and here is the real profit and here the predicted profit. Okay, so let's have a look. Let's take the first one. For the first startup here indexed by 0, the real profit is $103,000 and the predicted profit is also $103,000. Here it's 282 and here it's 15. So that's very close. That's an amazing prediction. So congratulations to our model. He made a good job on this one. Now let's take the second one. Second startup indexed by 1 in the test set. And so for this startup, the real profit is 144,259 and the predicted profit is 132,582. Okay, so that's not too bad, but obviously we congratulated our model too soon because it is obviously a less accurate prediction than the first one. Then the third one, the third startup, 146,000 here, 132, okay. Forest, $77,000 for the real profit, $71,000 for the predicted profit, not too bad. Here, not too bad as well. Here, okay. Here, okay, well. Here, perfect, a very accurate prediction, $97,000 for the real profit and $98,000 for the predicted profit. That's good. This one is very good too, $3,000 of difference. And finally, the last one, also a very accurate prediction, with only a little less than $2,000 of difference between the real profit and the predicted profit. Okay, so by looking at this test set real and predicted results, we can see that our model did a quite good job And mostly we can see that there is a multiple linear dependency between the independent variables and the dependent variable. However, in the last section of this part, regression, we will learn some better ways of evaluating our model performance, and we will be using some metrics to measure this model performance. But so far we have this, we can clearly see that there is a strong linear relationship between the two because we were able to fit a linear model to our data set of multiple variables. Okay, so let's click OK. And congratulations, you now know how to make a multiple linear regression model on Python. So in the next tutorials, we're going to do the same thing on R. You're going to see that some things are going to be more simple and some things are going to be better. We will be able to check very efficiently which are the variables that have the highest impact on the dependent variables. You'll see. I look forward to seeing you in the R tutorials, and until then, enjoy